Hi everyone, so welcome to the continuation of the lecture. Okay, so we are going to, I'm going to share my screen and continue right where we stopped earlier. Okay, so one second. So many things. Um, okay, I don't think that is going to work. Okay, yes. All right. So I hope it is visible to all of you. Are you able? No, it's not visible. Okay. So that's what to share. Okay, so let's just see. Yeah, okay. Right. So we will continue with what we had discussed and then add a little bit more. Okay, so we had looked at brain activation map. We had looked at prefrontal cortex and temporal areas which are activated during creative ideation. So we had already gone over it. So right now, I think we can continue with, I mentioned in the previous lecture that we would actually go over representational change, right? So we will actually look at representational change right now. Okay, so I will just explain representational change to you in detail. All right, um, because it is common to both default mode network and common to both default mode network and executive control network. Okay, so that is why it's important to go over it once again. Um, So just give me one moment, please. Let me just get everything together. One second. One second. I just wanted to give an example, so I have to kind of look at that. Just give me one moment. Right. So as we were discussing in the previous lecture, um, you know, representational change is common to both. RC is common to both um, default mode network, which is involved in processing creative thoughts and creative ideas, and executive control network, which is involved in logical thinking and reasoning. Right. So we are going to go over it right now. So representational change refers to the cognitive process of restructuring or reframing how a problem, concept, or idea is mentally encoded, often leading to breakthroughs in insight, innovation, or novel solutions. Okay, just one second. I'm not visible. You're presenting for my screen anyway. Right. So Yes. Okay. So you can see that representational change. Yeah, I think that is better. Representational change is common to executive control network and default mode network. So the concept draws from Gestalt psychology and theories like Sten Olsen's representational change theory. Okay, where initial mental fixations are overcome by altering the underlying representation of the problem. So neuroscience has increasingly linked representational change to large-scale brain networks, particularly the default mode network and the executive control network. Okay, and the default mode network encompasses regions like the medial prefrontal cortex. So we have looked at it, okay, which parts are the medial prefrontal cortex. And I'm just going to go back to the slide. Right, so the entire region around here is the prefrontal cortex, as you can see. And it involves the prefrontal cortex. It involves posterior cingulate cortex, or the PCC. Okay, we have looked at it, and a certain other regions that we don't need to actually get into. Okay, right now. So what it does is is all these particular areas is associated with internally directed cognition. Okay, so that is important to take into account. It involves introspection. Okay, and one second, I'm just kind of trying to figure it out. Um, right. Okay. So okay, okay, okay. So insight. So it is involved with insight. Okay, involving creative processes. All right. Um, and it involves spontaneous thought, memory retrieval, and associative processing. Okay, so that is very important to take into account. So previously, I had actually told you that the I had given the example of Marcel Proust eating a cake, okay, and then thinking about, and then suddenly the memories of his childhood and his youth coming into his mind. So that is an example of associative processing. Another, and also the fact is that uh, default mode network involves making connections between disparate paradigms or discourses. All right. So one good example of that would be the discovery of the carbon molecule. All right. So the manner in which Niels Bohr comes up with the carbon molecule, the form of the carbon molecule. So uh, previously, it carbon has four valence electrons. Okay, basically it means that it has one single carbon atom attached to four other atoms. Okay, four other hydrogen atoms, and because of that it can combine in a large number of ways with other molecules. And particularly it was very difficult to kind of find figure out how the molecule of carbon functions, and it would have been very difficult to actually think about the carbon molecule without kind of thinking about the carbon chain in this particular manner. Okay, so carbons can actually form, chains across with different carbon molecules as well. So particularly the molecule that we see, CH4. This is the most recent version of it actually, but prior to it being represented as carbon molecule, carbon atom surrounded by four hydrogen atoms, you find that you find that you find that it would have been very difficult to understand how it forms molecular bonds with other molecules without taking into account its tetrahedral structure. And that structure came to Niels Bohr in a dream. Okay, so he had a dream particularly where he, saw a snake eating its tail, and that is how he that is how he came up with the idea that the carbon molecule is probably, uh, you know, probably tetrahedral in shape. Okay, so that is important to consider. So that is an example of default mode thinking. Okay, so important to take that into account. It joins together different disparate paradigms of thought, and so that is an example of divergent thinking, particularly. Okay, combining different paradigms of thought. And then you have the executive control network, okay, which involves lateral prefrontal cortex, okay, inferior parietal lobule, and anterior cingulate cortex. We have already looked at it earlier, but we can just go over it once more. Just want to give you a sense of where it is situated. So this is the um, anterior cingulate cortex, all right, and it functions alongside the supplementary motor area, or the SMA, if you can see. So particularly, the executive control network involves lateral prefrontal cortex, all right, the inferior parietal lobule, and the anterior cingulate cortex that we see over here. Okay, and it supports goal-directed attention, cognitive flexibility, and inhibitory control. So as I mentioned to you earlier in the previous lecture, uh, executive control network functions by reducing your ability to connect different paradigms of thought, okay, which is central to default mode network. So executive control network inhibits that in order to enable you to do a do goal directed work. All right. So that is very significant to take into account. Next, while these networks are often anti-correlated, okay, we have looked at the overlaps, right? We have looked at the overlaps between uh, executive control network and default mode network. So they involve certain anti-correlated actions, okay, but at the same time there are some divergences as well. For example, executive control network focuses on convergent forms of thinking. So an example of a convergent form of thinking would be, the discovery of the periodic table and finding out that, that there are some gaps in the periodic table, and that those gaps can be filled if one can kind of, make intuitive uh, study of the elements and their atomic weight. All right, so that is actually a very significant example of convergent thinking. So for example, Dmitry Mendeleev came up with the periodic table, okay, in 1869. All right, and particularly, he had he organized 63 elements by increasing atomic weight. Okay, and then using the convergent logic, which is specific to executive control network, he predicted certain missing elements in the periodic table. All right, so for example, scandium, germanium, etc., and he identified gaps where properties did not fit patterns. Okay, so you find that there was systematic classification and deduction from empirical data converging on the table structure. So that is important to take note of. Right. Anyway, so let us look at, sorry about that, I'm feeling very thirsty. So in contrast, the ECN enforces structure. So yeah, so let us look at the roles of DMN and ECN in representational processes. So the DMN plays a pivotal role in generating diverse abstract representations by drawing on stored knowledge and facilitating free associative thinking. It supports the exploration of semantic spaces where distant concepts are linked through episodic memory or imagination, often without external constraints. For instance, during mind wandering, the default mode network enables the passive recombination of ideas, leading to novel representational configurations. So, it is crucial for divergent thinking in creativity, where broad, unstructured ideation precedes focused, refined work, okay, refined thought, because you are actually connecting different kinds of ideas, images. Okay, so for example, Niels Bohr's discovery of the carbon molecule, like I said, he was connecting the image of a snake eating its tail with the molecule of carbon. Okay, it's tetrahedral structure, which he had somehow intuited. So that is important to acknowledge. And then you find that the executive control network. Okay, let's go back to that particular slide. Um, yeah, so the executive control network. Executive control network enforces structure on the representations through top-down control. Okay, it inhibits habitual or irrelevant associations, evaluates potential solutions, and facilitates mental set shifting. Okay, directly aligning with representational change by overriding fixed encodings. Okay, in problem solving, the executive control network's relational integration and working memory functions functions allow for the deliberate manipulation of representations, such as reinterpreting elements in a puzzle. So it will actually help you to analyze problems, look at symbols, and then reinterpret them in a different context. Okay, so that is very significant. What makes representational change common to both networks? Okay, both default mode network and executive control network is that there are certain interdependent contributions from both. So the default mode network provides the raw material for change, while the executive control network implements and refines it. Okay, without integration, the default mode network might produce unfocused or irrelevant ideas, and the executive control network would remain stuck in rigid analytical modes. So the duality is evident in flow states where enhanced, default mode network and executive control network connectivity balances spontaneous generation with focused execution, reducing self-referential distractions and amplifying creative output. Okay, so that is important to take into account. The DMN might produce unfocused or irrelevant ideas, and then you find that because your brain is constantly, being in the in a one track mode form when it is operating in the executive control network, you find that they might kind of work against each other, like we mentioned in the first lecture. So the duality is obviously evident, but technically, the representational change helps balance both the functions of default mode network and executive control network. So it reduces self-referential distractions and amplifies creative output. So that is important to take into account. And I think we can kind of, go ahead and go ahead and look at some of the other arguments. So, multi-center fMRI studies, okay, what we are looking at are fMRI images. So, fMRI studies confirm that creativity predicts from default mode network and executive control network switching, with validation during idea generation showing higher switches than control tasks. Intracranial recordings highlight the default mode network as a gatekeeper for creative states, encoding cognitive shifts in low dimensional spaces, while attention networks regulate output quality via nonlinear high dimensional network representations. Okay, so important to take into account how both of them work. And also, it is important to acknowledge that DMN is associated with internal thinking, with introspection. Okay, and executive control network is involved with external focus. All right, and particularly you find that sometimes for patients who have undergone some kind of trauma and are in and face the post-traumatic stress disorder problem, you find that there is a disconnect between the way in which their DMN operates and the way in which their executive control network operates, and which that leads to an inability to balance functions. So they might be very introspective and unable to focus, okay, unable to direct attention towards external focus. And it is precisely because of a disconnect between the part of their brain that involves DMN function and the part of the brain that involves executive control function. So that is important to take into account. And so you have certain ways of overcoming such breaks in one's cognitive abilities, and one can always train cognitive flexibility. Okay. Uh, okay, and there is one very interesting book called The Telomere Effect. Okay, so the telomere effect is a very important book, particularly which I bought when I was living outside of India in 2017, and it kind of helped me overcome a lot of the stress that I was experiencing at the time. So telomere effect actually tells you that you can kind of actively reframe your negative thoughts. Okay, so that is a very, very important mental tool, and it is very important for problem solving, uh, for and for enhancing creativity. So that is a very important thing to take into consideration. Okay, so now we are going to look at common cognitive traits. We have just talked about it, but we'll just talk about it a little further. So, behavioral studies reinforce neural shares. Intelligence and creativity overlap in traits like cognitive flexibility, just as I mentioned, and analogical reasoning, with machine learning of fMRI data showing shared predictive patterns in frontoparietal networks. In visual creativity tasks, fMRI reveals overlapping activations in regions for divergent thinking and problem restructuring, such as the angular gyrus for semantic integration. Okay, so we don't need to go into all of that detail. What I have explained to you with regards to, representational change being common to both DMN function and ACN function. That is enough actually. So let us now look at the particular zones of zones of um, zones involved in DMN network and executive control network. Okay, so I'm just going to increase this size. So you can see that the blue region is part of the default mode network. Okay, so you have the hippocampus, you have the PHC. Okay, all of that actually is involved in your DMN activity. And like I said, it promotes divergent thinking, combines different kinds of disparate paradigms together, and helps enables divergent thinking. And it also promotes remote association. So that is important to take note of. Then you have, excuse me for 1 moment. Then you have activation areas involved in the executive control network. So the that area are the green areas, as you can see. So the exclusion of conventional ideas and meaningless ideas. All right. So executive control network helps differentiate between both. Okay, conventional ideas and meaningless ideas. It also helps break mental sets and form novel associations in solving insight problems. Okay, so like I said, it helps you make certain novel associations. That is slightly common to DMN network functions, but technically what it does is it helps you follow patterns. It helps you kind of perform goal directed tasks. All right, so that is your executive control network function. Next, you have the salience network. All right, so it allows for flexible switching between DMN and executive control network. And then you have creative output and improvisation, turning ideas into concrete actions. That is the pink region. Okay, so it's an important diagram, important to take into account how different parts of the brain function in order to kind of promote all of these different creative, works that we do and, solve problems. So it's important to take all of it into account. Then we are going to look at the differences. Okay, emphasis on novelty versus precision across domains. So while overlaps enable hybrid functioning, differences arise in network dominance, sub-process emphasis, and domain-specific adaptations. Creativity prioritizes breadth and novelty through heightened DMN activity and reduced inhibitory controls, fostering free association. Problem solving, conversely, amplifies executive control network for precision, feasibility, and evaluation, often within constrained contexts. Okay, so very significant to take into account. What it does is, like I said, creativity prioritizes breadth and novelty. All right, the wide range of thoughts that you have, and kind of looks for disparate contexts and connects them together in order to kind of come up with new thoughts. Whereas executive control network, as I mentioned, looks for precision in thinking. Okay, helps you evaluate, like the example I gave of Dmitry Mendeleev coming up with the periodic table, because he was evaluating the atomic weights of the molecules of the elements. All right, and then he discovered that there would be necessary gaps, which were just gaps in the periodic table to be filled by elements which would be discovered later. So that is an example of evaluation. And then generating a solution. Okay, because around his time it wasn't possible to kind of discover many of the elements that were discovered later on. So that is important to take note of. And then you have network dominance and sub processes. So a 2025 meta-analysis of fMRI studies, okay, the images that we have been looking at till now, distinguished creative generation, that is DMN heavy work, from evaluation, that is executive control network heavy work. Okay, creative generation involves more semantic reinterpretation via temporal lobes, while evaluation recruits IFJ for common integration, but with stronger executive control network for inhibiting irrelevant ideas. So, like I said, executive control network inhibits your irrelevant ideas so that you can do goal-oriented tasks better. Okay, in problem solving, it tilts towards convergent thinking. Okay, the example of the discovery or the creation of the periodic table, and it shares more neural overlaps with exploration than divergent thinking, which lacks such kind of co-activation. For instance, artistic creativity correlates with reduced prefrontal cortex constraints, okay, allowing vivid imagery and emotional input from the limbic system. So again, something that I mentioned earlier, the prefrontal cortex actually inhibits your your DMN network so that you can perform your more rigidified forms of thinking, following patterns, following logic, okay, following reasoning. So prefrontal cortex actually constrains DMN function. Artistic creativity correlates with reduced PFC. Um, sorry, uh, PFC, the prefrontal cortex, actually, that is not correct. The prefrontal cortex actually promotes artistic creativity. Okay, so it does not introduce reduction in DMN activity. It actually promotes it. So please excuse that. So artistic creativity correlates with reduced prefrontal cortex constraints, allowing vivid imagery and emotional input from the limbic system. Okay, scientific problem solving, however, boosts prefrontal cortex for logical integration. Okay, where executive control networks dominate in order to refine forms of hypothesis. Okay, so we are going to stop around at this point because we have discussed quite a lot, and then we will continue in the next lecture with our related area of study. So thank you so much for listening. I'm going to stop sharing. Okay, and conclude the recording. So thank you so much for listening, and I will create another lecture very soon.